Assalamualaikum. Today, my name is HAZRIQ and I will show you how to undergo the experiment of force convection. So, first of all, please switch on the main power. And second is turn on the secondary power. Alright, after we've done the turn on the secondary power, and the third step is tune the power to the 30 watt as the initial power. As you can see now, the power has turned to 30 watt. Now, for the force convection, we use probe. We use probe for the third temperature. Please replace the T3 or temperature 3 with a probe to gain the temperature. After that, set the airflow to 3.0 meter per second. Now we done set the airflow to 3 meter per second. Now we use the probe to gain the temperature, and the probe is represented for T3 or temperature 3. How we use the probe? As you can see now, we use the probe to gain position 1, position 2, position 3, 4 and hands on. So to get the position 1, as it's mentioned on the lab sheet, position 1 is located at the nearest left. So this is the left hole to gain the temperature from the probe. So as you can see now, the current temperature now is 31.1. The second position of the temperature 3 for the probe is second position for the probe is for temperature 3 is 33.1 Celsius. Third position for the temperature number 3 is 33.2 Celsius. The temperature number 3 for position 4 is 30.4 Celsius. Next is position number 5 for temperature number 3. Now for the data number 6 for our pin, it is 38.2.
For the next experiment, we change from pin to fin surface. And first step, we lock this pin and lock for the first. We change it for the fin. Jadi tu tak ada banyak import And now we repeat the experiment same as the first step. For the startup, we use the same step for the first experiment, and then repeat the step 1 for the position number 1. And we collect the data from the and from the result we get 27.5. And for the second position of our temperature we get 26.8 Celsius. And for the third position, our group got 26.2, and for the fourth position, we got 25.6 Celsius. For the fifth position, our data show our group get 25.8. For the sixth position, our group get 25.6 Celsius.
A very good day, sir. My name is HARISHWAR MOHAN from BMMH3553. So today we are going to discuss on the lab 4 discussion, first convection discussions. The first question will be create a chart of temperature vertical axis against probe position along the pin or fin. Then the next question is add free and forced convection results. So this is the forced convection graph for pin as shown from the probe position. The first position, the temperature will be 35.7. The second position, the temperature will be 32.5. For the third, 30.3. For the fourth, 29.1. And for the fifth position, 28.8 degrees Celsius. And for the sixth, the sixth position, 28.5. Then these are the forced convection result for pin surface and fin surface, and this will be free convection results. The next question will be calculate and compare the difference in gradient between free and forced convection for each surface. So here our gradient for forced convection graph with gradient for pin. So we choose pin as to find out the gradient. So these are the gradient. Y equals to negative 1.38x plus 35.647. So this is the free convection graph with gradient for pin. The y equals to 0.8009x plus 22.977. So as a gradient comparison, while we comparing the gradient between forced convection and free convection for pin surface, forced convection went into a negative gradient. This explains the temperature keeps on decreasing gradually when move the position from left to right. Meanwhile, free convection became a positive gradient. This indicates that the temperature increases gradually when the power watt increased. So that's all from me, sir. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ADIE ZULFIKRI bin MAZLAN. So I will continue about the discussion Number 3, based on the collected data, we can say that the fin surface are better than pin surface in total heat dissipation along the extended surface, because fin surface have larger amount of total heat dissipated at larger surface. So the heat can be spread easily and faster than pin surface. The answer number 4, if the experiment using aluminium or copper, the temperature gradient will become decreased linearly and increasing the overall efficiency of heat dissipated. Based on the laboratory's activities, we conclude that first, we must always follow the safety precautions to avoid unwanted harm things occur to us. Second, follow the instructions that given by instructor and lab sheet to perform the laboratory activities correctly. Third, collected data shows forced convection on fin surface are better than pin surface because of larger heat dissipation surface. Fourth, able to show the temperature distribution gradient along a pin or fin heat transfer surface in forced convection. Last but not least, able to operate machine or equipment properly while experiment.